After having had our experience with the flood control model, we now move to the wetland products model. The most important thing about this model, it has been featured in most of the water accounts when it comes to natural capital accounting. And what is unique about it is that we know most of the water accounts would consider the fish production or the animal products that emanate from the wetlands. You find it is ignored the other products that may come from the wetlands, such as plant non-woody based products such as reeds and papyrus, and even things like coral shells, stones, and things like that that would come from wetland. But this wetland product model has considered every other product that can be obtained from the wetland. So according to Ramsar Convention, wetlands are considered among the most productive ecosystems in the world. They provide a transition between the aquatic and the terrestrial environment, having features of the two. Therefore, wetlands provide a consistent food supply, not just for the human beings, but also for animals and a wide range of biodiversity. They also provide shelter, nursery grounds for breeding both in marine and freshwater species. They as well provide a very healthy growing environment for wetland vegetation and a good harbor for other wetland products. This model, therefore, considers three main categories of wetland products, just like I've highlighted before, with separate submodels developed for each. We have the first submodel, which is the animal product. This is what we're going to be running today, because like I said, for the purposes of summation, we are going to have one terrestrial ecosystem. We did the forest yesterday, and today we are having the wetland ecosystem, where we are going to run three submodels that will give us products that we can visualize when the summation has been done. The next one is the plant-based non-woody plant from wetlands. We have the papyrus, the reeds, and other grasses, and leaves that can be used for weaving and making baskets and mats, thatching of houses, fodder for animals, and the production of traditional artifacts. This is a common scenario along Lake Victoria in Kenya. I don't know about other countries that we share the boundary of Lake Victoria. We also have non-animal wetland products. These precious stones, coral shells, sand, salt, soda ash, and some food staples. We have salt in Djibouti. That is one of the countries we received a hotspot area that required a hotspot area of degradation that required intervention. We had soda ash, I believe, in Ethiopia, and so on. So each one of the wetlands has something good that can come out of it, and therefore it is important to capture this information and be able to value it. Then finally, we have the wood-based energy and timber products. This is the vegetation, the woody vegetation that would grow in close proximity to the wetland or actually inside the wetland. For example, we have the mangrove vegetation along the Kenyan coast. It's also in the Tanzanian coast, and I believe part of Somalia. We therefore move in to understand what are the biophysical assessment or the biophysical indicators that we need to consider for us to be able to calculate measurements that can be valued. So this particular model considers a mass or number of wetland products harvested as the key indicator for the biophysical assessment. The model allows for the segregation of wetlands to depict the many harvesting areas or fishing zones found within the wetland ecosystem, and for which localized data on the amount of harvested products and associated unit values can be delimited to. So what is the economic assessment? The model employs the direct market method valuation technique for the monetization of quantified ecosystem. For example, what are we saying? When we delimit the areas, the fishing areas, and we're able to know the units of fish that are obtained in that area, then we should be in a position to know what is the price of fish that is coming from that particular area. So in summary, we are saying that the model for the valuation of wetland products as an ecosystem service from wetland ecosystem considers the value to be equivalent to the revenues collected from the sale of any wetland product, be it animal product, be it plant-based non-woody, or any other collection of products that come from the wetland. And the valuation is done based on the prevailing market value of the harvested products. So what are the data requirements? One, we look at the attribute table of the animal product. Like I said, we have three submodels. So we start with the attribute table of animal products and the data requirements. One, you need the wetland raster, the number of fish harvested, the count, the unit cost of fish, like I've discussed, in the applicable currency, maybe your local currency, or you may want to do it in dollars, areas of fishing zones, These are demarcated areas that currently there may not be available GIS data, but local available experts can be able to show you, and you're in a position to demarcate these fishing zones with GIS data for the purposes of this particular valuation in this model. Then finally, you put the pixel area in meters squared, like we have advocated for in most of the models that we have gone through together. For the plant-based non-woody wetland products, the data requirements are such that you put the wetland raster, you have the mass of product being harvested in tons, and then also the unit cost of the products being harvested in the applicable currency, the area that is being harvested. You look at things like papyrus and reeds, you must be in a position to see the area that is being harvested to produce that product for the purposes of valuation. Then finally, you input the pixel area of input raster data. In the data preparation for the wetland product, we have some considerations that you must put in place. Number A, we have the preparation of the input data for the wetland raster, and we recommend you digitize or physically define the fishing zone areas or harvesting areas in the wetland. The digitization can be done either from a satellite imagery, a photograph, a topographical map, or other sources that can provide geographical boundaries. When you're digitizing this, you should consult the local expert knowledge, because they're in a position to actually be able to tell you where the fishing zone boundaries are. Once this vector data has been collected, depicting the fishing zone areas, then you rasterize it, and the output number of classes must match the fishing zone area in the wetland that appears in the table. Alternatively, you can do a land cover classes, then relate the various fishing zone areas, and similarly, the output number of classes for the fishing zones raster must depict the number of individual fishing zones within the wetland that appears in the table. The attribute table of the fishing zone or harvesting area must have a unique ID column that matches the pixel value column of the raster that is specific to the respective fishing zones. It is important to note at this stage, when we are talking about the fishing zone areas, we found them that they exist. When we went down to carry out our case study of the socioeconomic valuation of mangrove ecosystem, we found one of the fishing zone areas within Watame area had been closed down because there was degradation of biodiversity as a result of the fishing methods. So the attribute table for the fishing zone for the raster should appear as follows. You see the value, the count, the unique ID, and the fishing zones. Where I have retaliated before that, let the unique ID have the numbers that will be similar to the CSV file or the CSV table that you'll be loading, so that you can be able to upload the data from the CSV table to this attribute table for the raster. Under the data preparation of input attraction site table, these are some of the key considerations that we must make, that this table must be prepared in a comma-separated value format like we have retaliated before. The table must consist of the requisite data for the respective fishing zones or harvesting areas captured in the respective rasters. The data required is the number of fish harvested for each individual fishing zone, the unit cost of fish, and the fishing zone surface area of the harvested area in that particular wetland. So once you have prepared your table with the respective data sets that are required, you must always make sure it has a unique ID column that matches the unique ID column of the input respective rasters. The unique ID should also be specific to the respective fishing zone area of harvesting as they appear in the rasters. You can see the example below of the table that we have put across. You can see the unique ID, and I'm sure you saw the unique ID that we showcased of the raster in the previous slides. So for the non-woody products, we have almost something similar. For the plant-based non-woody wetland product, would have the harvesting area, the different harvesting area. Same case, you must have a unique ID that will match up to the unique ID within the raster, the mass of product in terms of tons, what is being harvested where, and the unit cost of the product, and then the harvesting zone area. So now, since you have understood all the data preparations and what the wetland product model is all about and the submodels that are within it, we can now basically move to the wetland product model, run it for the fish product. Once you get time, you can also be able to run the other submodels and be able to give us a feedback. So when you open your wetland submodel, you should have the animal product submodel as the first one, the plant-based non-wood and other products, and finally the wood-based product and a summation of the same at the end. So we'll run the animal products, we'll input the wetland raster just as discussed during the data requirements and data preparation procedures. So from our folder where we have our input data, we'll be able to load the data sets required for this. We have wetland product, the Kariba Dam. Like I said, we are working with Kariba Dam in Zimbabwe. So you see under unique ID, wetland raster, the value is actually the unique ID that needs to be picked. And then we load the CSV file that we have discussed and the manner in which you should prepare it. The fish CSV file. And then the unique ID for wetland product attribute table is the object ID that has the same number of rows or the same number of fishing zones that are also within the wetland raster. So we start with the fish unit value, which is the number of fish. The fish unit value per area, the number of fish, the wetland fishing area, and then now we can be able to input the pixel area and designate an output folder where we would want our work saved. So we'll designate the output data folder that I've been using for this particular training. So once all your data sets have been loaded, you are ready to run the model. You allow it to run. It may take a bit of some time. So the wetland has finished successfully. The wetland product model has finished successfully. And we say okay. And then we can be able to move to the QGIS to now visualize what kind of a product that we have been able to get for this model. We can now load the wetland product, add raster. So we have our animal products value raster. We add it. So based on the data provided, what happens is that the model picks up all the fishing zone areas and sums them up and be able to provide us with the data that at pixel level for the animal product value raster. So you can be able to see there that we have three products or three ecosystem services that we can be able to sum up and get a value of this raster. So tomorrow, as we engage further, we'll be able to look at other services. Thank you for being with us in the session today. We're now open for the question and answer sessions and also comments and experiences at the chat about the usage of these particular models. Thank you for being with us.